Good morning, student. How's everyone doing? Anyone have any questions? All right, today we're going to continue with chapter 4. Right, we did cover up to section 4.6 today. On Monday, today we're going to continue with section 4.7. We talk about decision making, and then we said that basically you can use the if statement to make decisions, and you can use one-way decision using the if then statement, and you can make two-way decisions using the if then else statement, and you can make multi-way decision using if then else if statement, right? But when you make decision, you have to compare values, all right? So we talk about relation operators, so you can check if a value is greater than another value, or less than, or not equal, or greater or equal, or less or equal. So we talk about relation operators. However, this concept of comparing things is not only limited to numbers. You can apply it also to text, to strings, and that's what we're going to talk about in section 4.7. So you can, if you like, relational operator can be used to compare strings and string literals, right? So for example, you can have two strings in here. You can have a string name 1 for Mary and string name 2 for Mark, and you can compare them. And to see how they relate, if they are equal, if one is greater than the other, etc. So let me show you what happened when you compare values, right? When you compare a string. So I'm going to go ahead and switch to the projector. And basically what's happened when you compare string, and here you compare strings are compared character by character. So you have in here Mary, and there is Mark, right? So you can view this thing as a string of characters, 4 characters, right? And here you can view it as a string of 4 characters. And what happened when you compare strings, the system compared it character by character. Compare the letter M with the letter M and see which one is bigger, right? So there's no difference in here. They are the same letter. So compare the next 2 characters, the small letter A and the small letter B. Again, there's no difference, so it cannot make a judgment. So it goes to the next character, small r and small r, they are the same. Finally, it compared the y's, the y in Mary and the k in Mark, and you can see that y is greater than k, right? Because y is greater than k, this implies that basically Mary is greater than Mark. And this is how you compare string. You compare them character by character, right? So let me show you how does a computer system encode letters. The capital A, the letter capital A, is encoded as a number. This is number 65, right? If you take the capital character B, it's encoded as 66, right? 66, etc. C is 67. So they encode it numerically, and you're comparing numbers basically, right? You can go all the way to Z, right? And then guess what? The smaller alphabet comes after the capital alphabet. So the letter A is encoded as 97, right? And the small letter B is encoded as 98, etc. Because of that, you can see that the ASCII code, which is a American Standard for Communication Interface Coding Scheme, the ASCII code of A, which is 97, is greater than the ASCII code of capital A, which is 65. So if you're comparing 2 strings, one is have lowercase a and one that have uppercase a, the strings that have a lowercase will be bigger than the string that have a lowercase, and this is how you compare them, right? It doesn't matter how many characters you have. So you may have in here character, you may have in here the string A, and you have the string in here X, Y, Z, right? Looking at this one, since X is in here is a capital X, it's still smaller than lowercase a, because you compare them the first character by the first character, so this is still bigger, right? So this is how you compare string. You compare them character by character using in accordance with the ASCII code scheme that is used to code characters in computers memory. So, so in this case, you can compare Mark and Mary to see if they are equal. And of course, they're not going to be equal. So if str name 1 equal str name 2, it is not. It's going to say name are not the same because, of course, the last letter is Y in Mary and K in Mark, so it's not the same. You can compare in here the months to see if it's equal to a specific month, like October, and if it is, then you can do something like that, right? So how strings are compared? Strings are compared character by character. Characters are stored as numeric values. These are use Unicode. Unicode is the latest coding scheme. The previous one was the ASCII coding scheme. Both Unicode and ASCII use the same characters, basically. Unicode use also 65 for capital A and 66 for capital B. It uses the same thing. The difference is the Unicode accommodate more letters. So Unicode uses 16 bits, while ASCII uses only 8 bits. All right. This gives you the Unicode give you many characters. You can represent 2 to the power 16 up to 65,000, more than 65,000 characters in it, right? As opposed when you look at, if you're looking at the ASCII, which only support 256 characters. So you can store much more numbers and much more characters with the Unicode scheme. And it is now with the computer hardware becoming inexpensive, it's becoming more and more widely used. The Unicode is more and more widely used. Visual Basic does use the Unicode basically. So it compare characters based on the Unicode values, like 95 for 97 for capital A, etc. Right. So the Unicode numbering system represents all letters of the alphabet, printable characters 0 through 9, punctuation symbol, and other special characters. Letter A, B, C are arranged alphabetically. So the letter A have the Unicode value, let's say 97. Letter B have Unicode value of, Unicode A has a value, Unicode value of 65. Capital B is 66, 67. So you can compare them. The numeric value of A is less than the numeric value of B because 65 is less than 66, etc. So you can compare them that way. So in this case, you compare Mary and Mark character by character. The M's are the same Unicode value for MAR, but when you get to the Y Unicode value is bigger than the K Unicode value, so Mary is greater than Mark. You can, another thing you can do, an important thing, and as we get into chapter 4, you're gonna learn a technique called validation. And validation is very important in programming. You have to make sure your input is correct. There is a saying that a garbage in is garbage out. If the input is invalid, then the result is invalid. So that's why you have to validate the input, make sure that the input is valid. And one important validation is checking that basically the user has entered value in required field. For example, if you have a form that asks the user to enter the name of a person, the person have the name of the person is a required field, so you have to make sure that the user actually did put some values there, right? This is how you can check for required field. You can compare the string, right, like txt input, for example, that text, you can compare that with the empty string, right? See if it is equal to empty. If it is empty, then you display an error message. Please enter a value. This is a required field. You have to enter a value, right? So display a message, right? Else, you do the processing. So you can do that. You can use, if you like, either string empty, right? Or you can use two double quotes, double quote with nothing in between, which is an empty string, right? So this is just very important to note that, right? So if you want to represent an empty string, you would use two double quotes. This to represent an empty string. You can use that, or you can use string that empty. Both of them mean the same thing. So both of them represent the same value. I like to use this thing, two double quote with nothing in between, because it's less typing. Double quote, double quote. So I could have done that in here. I could have said if txt input that text equal double quote, nothing in between. If it's empty, basically, then please enter a value. This is useful to determining whether the user has provided input for a required field before performing operation on that field. So this is the purpose of it. You can also do some other operation with string. You can convert to uppercase and to lowercase. There's two functions provided to do that. One is called to upper, one is called to lower, right? The to upper, as the name imply, it will convert lowercase to uppercase. So if you have, for example, the string in this example, if we have a string hello, right, which is not all uppercase, right? Only the first letter is capitalized and it's followed by lowercase letter. If you use, and this is called str little word. If you say in here str little word, that to upper is going to convert the value stored in str little word, which is hello in lowercase, to uppercase. And it's going to store the result in str big word. So big word is going to have hello all capital. Going to have all capital letter. Now, this doesn't change a little word. Little word is still going to have the same string. It's not going to change the content. But since you're assigning this thing that to upper, you're assigning it to str big word variable. Str big word is going to have hello all capital letter. Same thing, same concept. You can use the to lower function to convert to lowercase, right? For example, if you define str little town, okay, to equal New York. Sorry, if you define str big town to equal to New York, all uppercase letter, right? Then if you say str big town to lower, this is going to return the lowercase version of New York, and it's going to store it in str little town. So str little town is going to have New York lowercase letter. So basically that's what happened. So these are some functions that are available. You're not going to use them in the exercises that are assigned to you for chapter 4, but they are available for if you need that, right? The to upper and to lower function are good to use case insensitive comparison, right? For example, if you try to compare the two string hello uppercase with the string hello lowercase, they are not equal, right? Even though they have the same message, which is a greeting, they are not equal because the ASCII code for uppercase H is different than the ASCII code for lowercase h. So they are not equal, right? So to do case insensitive comparison, that means regardless of the case, you just compare the content. Then you can use a to lower function or to upper function to do that. For example, if you take in here str word 1, right? It have hello all uppercase letter. And if you take str word 2, also to have all it have hello but all lowercase letter, right? Now if you try to compare word 1 with word 2, they're not going to match, right? Because uppercase is different than lowercase, so it's going to be false, not equal. But if you use the to lower function or to upper function with them, if you say str word 1 dot to lower, it's going to give you hello in lowercase, equal str word 2 to lower is going to give you hello lowercase. They're going to be equal, right? And this is how you can do case insensitive comparison. So regardless if you enter lowercase or uppercase, it's going to give you true. So you can do that. You can assign, if you like, any string characters to a string. So if you like, you can do something like this. You can declare a string variable, str number, as string, and you can assign this string 576. This is a string, not a number. Be careful. It is not a number. It's different than 576, right? Um, uh, this is very, very important things to remember about characters, right? And some people may, you need to distinguish between the two, right? There is a character in here too, and there's a character 10, character string. And there is a number 2, and there's a number 10, right? Now this one, 2 is, as a number, 2 is less than 10, right? Numerically, 2 is less than 10. But as a string, if you remember, you compare string character by character, right? So you compare string character by character. So you have in here the string in here 2, and the string 1 0. You compare it character by character. Is 2 greater than 1? It is. So you AND. The string 2 is greater than string 10. So you have to be careful with that. So that's why always you need to convert your string to numbers. Otherwise, you may get incorrect result, right? So that's why it's important to do this conversion, right? So there is a function that can allow you to check if the string contain number, it have valid number. It's called the isNumeric function. So the isNumeric is going to return true if the string argument is numeric. And it's going to return false if the string argument is not numeric. For example, if you store in str number 1, 2, 3, ABC, you're not going to be able to convert that to a number. So it's isNumeric going to return false because it's not a number, right? So use isNumeric function to determine if a given string contains numeric data. It's one way you can do to validate that, to make sure that the input is valid. Okay, you can find the length of a string using the length variable, right? For example, if you take the string str name containing Herman, right? Now, if you count how many characters in that string, there are 6 characters here, right? If you want to get this length, you can simply use strname.length. So when you say strname.length, you're going to get 6. So int num character is going to give you 6 in this case, because there's 6 characters. You can use this technique to validate the input. Like for example, maybe let's say you want a user to enter the employee number or the student ID, and you want to make sure that the user enter exactly 4 characters, 4 digits, right? So you can use the length method to verify that, right? So for example, if you can only allow input up to 20 character long, you can do validation to check if txt input.text.length, right, is greater than 20. If it's greater than 20, then you can display an error message, please enter no more than 20 characters. So this is this other validation you can use by using the string function, like the length. There's many other string function. We're not, this is optional topic, by the way, so it's not, we're not gonna see that in the exercises that you need to do. But you can do a function like trimming function to trim leading spaces from beginning of the string. There's a trim and to trim trailing spaces from the end of the string. And there's a string, and there's a trim function that remove leading and trailing spaces. Here's an example. If you have the str greeting is hello with leading spaces, let's see, we have maybe 3 character or 4 character leading spaces and another 3 or 4 character trailing spaces. Now, if you use in here LBL message that text to equal str greeting that trim start, is going to give you, is going to trim, remove the leading spaces, but it's going to keep the trailing spaces. If you say trim and, is going to remove the trailing spaces, keep the leading spaces. If you say trim, is going to move both leading and trailing spaces. So these have some uses. Sometimes you may want to use them, but they're available. Again, you're not going to see example. There's no exercises for you to do on this topic, which is an optional topic. You can use a substring method. Again, this is an optional topic to find a string or to extract a string from within a string, right? The syntax of it, it have two sets syntax, all right? First syntax, you can extract from the start position till the end of the string, right? So start from beginning till the end of the string, right? The second one, you can extract from the start position a specified number of character, right, from the string, right? The first character is always position 0. Very important. The string start at position 0, right? Let's do examples so you see that. This is best on to address to example. So let's say here George Washington, okay? So I'm gonna go ahead and turn the projector on and see how this work. So we have the string now. It's important to realize that the first character of the string it position at position 0. So this is character position at position 0, not 1. And this is position at 1. This is 2. This is 3. The R. This is 4. This is 5. Right? This is 6. This is 7. Right? So the W is at 7. Right? Okay. When you say in here, if you take this thing, if you say in here, string name, str full name, that substring 7 is going to extract everything from position 7, right? But position 7 is a Washington, is a W. So it's going to take everything from the W all the way to the end. It's going to give you Washington. So this will extract the string Washington. It's going to give you basically the last name, give you Washington, right? But you can do different way. You can the second syntax, you can specify 2 parameters with the substring, the start position and the number of character, right? So if you do in here, if you start at 0 and extract 6 character, what this is gonna do is gonna start at position 0, which is a J, G, and then extract 6 character, 1, 2, 3, 4, 5, 6. So it's gonna give you George. So you can use that, all right? Again, you can do substring functions to do that, right? So I'll give you George in here. Okay, again, you're not gonna have any exercises that has to do with string manipulations, but these are functions will help you do that. Many times the substring you use it with with another function that will allow you to locate the limiter, because you're not gonna always have the same name, George Washington. Sometimes you may get other name. So in this case, like Thomas Jefferson or whatever it is. So in this case, it's important to locate the space, because this is what separate the first name from the last name. And once you locate the space, you'll be able to extract the first name and last name. Now, there's a function that allows you to locate certain character in its string. And this function is usually used with the substring function. This function is the index of function, which allow you to locate a character inside or a substring inside the string, right? It does have different format. You can locate the substring starting from 0, you start searching from beginning of the string using just a search string. But you can do another argument where you can start to locate the search string, but instead of starting at 0, you start from the start position. So you can specify that. And still there is a third way to do that, is by searching for the substring, okay, starting at the start position and only search up to a maximum number of character, up to count number of character. Right? Let's go do the example to see that. In this case, we have Engineer Adams. If you count the character, this is position 0 of the string, the A, but there's another A at position 9, right? So if you start searching from 1, right, is gonna locate the position for the last name Adams. It's gonna give you 9, which is where the last name start. So if you don't put a start position, it's gonna give you 0, which is the position of Angelina. Again, this is just for information. They're not going to be exercises for you to do from this thing. You need to know, however, for multiple choice question, they may ask question about that, so you should know how be aware of that too. Any questions? All right, so the important section 4.8 is more interesting, is a select case statement. All right, I did cover that little bit in on Monday, I think. When you do multi-way selection, we said that you can do multi-way selection by using if, else if, else if, else if, which is great. You can use the else if as many for all application you can think of. But for certain application, the select case, there's an easier way to do that, and this is a select case statement. Select case statement allows you to do multi-way selections. So it is similar to the if then else if statement, that it performs a series of tests, conditionally executing the first two conditions. So it's that aspect is similar to that. The select case statement, however, is different in that there is only a single test expression. So if your decision making is based on a single decision, single expression, then you can use a select case. If your decision is based on two expression, then you cannot use select case. For example, if you remember the example we did on Monday, we did an example on seeing if a person qualify for a loan. And we said that the condition to qualify for a loan is he must be at least 2 years on the job, and he must have a salary at least 30,000. So in this case, there's two conditions. The decision is based not just on the years, but also on the salary. Because your decision is based on two expressions, you cannot use select case statement. If your decision, however, is based on only one expression, such as computing the letter grade, it's based only on the average, then you can use select case statement. So when your select decision is based on a single expression, then select case is a good choice to use. The text expression is listed once. You don't have the advantage of using select case is you don't have to repeat the text expression. You list it only one time. The possible value at expression of the expression are then listed with their conditional statement. You can use a trailing else. This is called the case else at the end, that if the expression doesn't match any of the values, it will match the case else at the end. Let's look at that. Right. This is the syntax of it. So you select at the beginning, you select case test expression. For example, the test expression can be as simple as a variable name. For example, you can say select case average, maybe, right? Then you put your cases. Case expression 1, case expression list 2, case expression list 3, as many times as you want. At the end, you say case else. Okay. Again, best way to see that is through examples. Let's go ahead and look at some example. Right. Here's an example. Right. This is a good example of using the select case statement. Right. Depending on what we enter in the TXT input text box, we're going to display the day of the week. Right. If we entered 1, case 1, when you say 1, that means the expression, TXT input, that text is 1. If it is 1, then we say day 1 is Monday. If it is 2, again, and here 2 is the expression, TXT input, that text, after converting to an integer. If it is 2, then you say day 2 is Tuesday, etc. If it's 3, is Wednesday, all the way. If it doesn't match any of the number 1 through 7, it goes to the case else, where it displays that value is invalid. Okay, so this is simple expression example, but you can do more powerful thing. This is simple, and here is very simple. You can, if you want, you can list of value. You can separate them by commas. You can do more stuff with that. Here's another example. So it's basically what happened. You're testing the expression. If it have a value 1, you say it's a Monday. If you have a value 2, you say it's a Tuesday. If value 3, you do operation 3, etc. So this is the logic behind it, right? So this is basically the select case statement that we just did, right? But you can do something more, right? You can do something, you can put a list of values, right? So you can say in here, select case int number. You can check an integer to see if it is odd or even. If it is 1, 3, 5, 7, or 9, then we can set the status to be odd. If it is 4, 2, 4, 6, 8, or 10, we set the status to be even. If it is none of these numbers, we say it's out of range. We handle on the number 1 through 10. Right? So this is an example of using case select case. You can list values, separate by commas, right? But you can do more than that. You can use ranges if you like, right? You can use a relation operator, okay? You can check the temperature, select case DBL temperature, right? You can say case is. Whenever you use is, you're referring to the expression that is DBL temperature. So is mean if DBL temperature less or equal to 75, then we'll say too cold is true. Is greater or equal to 100, that means DBL temperature greater or equal to 100, and BN too hot is true. Case else, that means it's between 75 and 100. You would put the flag BN just right to be true, right? So you can do that. You can use the is operator, is with a relation operator. Okay. So you can do anything you like with if your decision making is based on a single expression. If your decision making is based on multiple expression, you have to use the if else, if. You can do ranges to check basically a letter grade, for example, right? You can do something like this, select case int score. And you can say if it is that mean the int score is greater or equal to 90, then it's an A, right? If it is not greater or equal to 90, check if it is between 80 and 89, 80 to 89, then it's a B. Then you can check if it is 70 to 79, then it's a C. Then you can check 60 to 69, then it's a D. And you can check 0 to 59 is an F. Otherwise, it's an invalid score. Now, you be careful when you use this thing, when you use ranges, right? When you use ranges, make sure you are checking that the expression is an integer expression, right? Make sure whatever expression you have in the select case is an integer expression. Because guess what? Double or floating point expression, you cannot limit them in a range, right? Because you have an infinite number of value between the number 79 and 80, right? There's infinite number of values between 79 and 80. You can have 79.1. You can have 79.0001. So you cannot really use ranges with floating point values. So if you have a floating point value, it's important to convert that floating point value to an integer with the CINT function before you do that. Otherwise, you may run into trouble, or you may get incorrect result, right? Just give you a simple example. Let's say that the average, if it was a double, if it's DBL score, not the integer score. If it was a double and the average, let's say, was 79.5, right? This should be C or B, right? Right. But what's going to happen is not going to match any of the ranges, right? It is not greater than 90. It is not between 80 and 89 because it's 79.5. It's not between 70 and 79. Again, it's 79.5. And it, of course, it's not between 60 and 69 or 0 and 59. So it's going to match the else. It's going to say invalid score. But it is a valid score. 79.5 is a valid grade, but it's going to give you invalid score. So be careful when you have an expression that is not integer. You have to have the requirement the expression has to be an integer when you use ranges. So keep that in mind. All right, let's go ahead and do some example. All right, before we continue, we'll talk about input validation. I already prepared a form for that. And And we're gonna go with a crazy Al commission calculator. So we have that, right? The idea is we're gonna compute commission based on the following commission rates, right? I'm gonna go ahead and switch to the projector. Okay. Okay. Yeah. Then basically, we say that based on how much sales a salesperson do, you're going to get a commission rate, right? So if a salesperson sell less than $10,000, right, worth of merchandise, he'll get 5% commission, right? But if you sell between 10,000 and 14,999, he'll get 10% commission, right? This is based on 10% of the sales, right? If you do 15,000 to 17,999, you get 12% commission, and then between 18,000 and 21,999 is 14%, and between 22,000 and or more, you get 16% commission. So basically, that's how you're gonna give commission to salespeople. All right. So we need to write a program to do that. So basically, we have this form, and the form will accept the sales amount, is going to accept an advance pay, okay? Then compute the commission rate. The commission rate based on the table I just showed you. And then we're going to compute the commission, which is the commission rate times the sales. And then we'll compute the net pay, which is the commission minus the advance pay, right? So I already named these label. This is TXT sales. This is TXT advance pay. This is the LBL commission rate. This is LBL commission, and this is LBL net pay, right? And this is beta and calculate, of course. Let's go ahead and program it. Right, I'm gonna go ahead and hide these property window and the toolbox window because we don't need it. And I can go with the same methodology if you like. Step 0, everybody should know these steps, is you basically declare variables. How many variables we need to declare? You need to declare one variable for each input, one variable for each output. Let's look at this thing. So we have 2 input and 3 output, so we need 5 variables, all right? Everything is money and commission rate, so they are all floating point numbers. They're gonna be all doubles. All right, so let's go ahead and declare them. DBL. So because they double, I prefix it with DBL. The author like to use DEC, so you would see that in the book. I like to use double DBL. All right, so we're gonna have sales in here as double. We're gonna have DBL, what the other one was, advance pay. And then we have them DBL commission rate as double. And then we have them DBL commission as double. And then we have net pay, DBL net pay. Right, so we have that. Okay, so we have step 0 to do that, and then you're gonna put basically your try catch block, right? Right. I'm gonna do only one. I can do multiple one for each input. Actually, let's do 2 of them. We have 2 inputs, so we need 2 of them. The first one is for the. I'm gonna put in here. Let me see if I put the status label there. No, I didn't. Okay, so I'll use a message box in here. Right, the first one is for the first text box, right? Which is the sales. And we're going to say TXT, say sales should be numeric. Right? This is the first one, and I'm gonna basically, if I did an error in the sales field, I wanna put the focus on the sales field, TXT sales. Dot focus. And I wanna select all the text in that field, TXT sales. Dot select all. Right. So this, the first one is basically you try to input the sales, which is you're gonna say DBL sales equal, and since it's a double, you have to use a CDBL function to convert to double. TXT sales dot text. Right. So this is the first one. Okay. One or two things going to happen. If you enter a non-numeric value for the sales, it's going to throw it to the catch block, and it's going to display an error message. Sales must be numeric. It's going to take you to the sales text box. It's going to select all the text so you can replace it with valid values. The other condition is it may be successful. If you enter numeric value, it's going to convert it to double, store the converted value in DBL double, and then you can continue. If you want to continue, you have to do another try block to try to read the next value, which is the advanced pay. So we're gonna check in here again. If it fails, we have to go to display an error message. Saying that advanced pay should be numeric. So we display an error message, and then we put the focus again on the TXT advanced pay. So we'll go to that field. And we select all the text in that field. So basically that's what we're doing here. We're gonna try to get the advanced pay, DBL advanced pay, to equal to CDBL, try to convert it to a number, to a double, TXT advanced pay, that text. Right, so basically that's what it does. It tried to convert the advanced pay to a number, to a double. If it fails, it's going to throw it to the inner catch block. Let's say advanced pay should be numeric, and it's going to take you to that advanced pay text box, and then it's going to select all the text so you can correct the entry. Right, if it's okay, and then you would do in here step 2 inside the innermost try block. Step 2 you would do in here processing, which is basically computing the gross pay, right? Computing the commission, right? But the commission is not an easy thing to do. The commission is based on this table, right? So you can get, it's not just one outcome, it's multiple outcome. You may get 5 different outcomes, right? You may have 5%, 10%, 12, 14, 16, depending on the sales amount, right? This is a good case for a select case statement. This is a perfect example where you can use select case statement, because your decision is based on a single expression, which is the sales, how much sales you have. So we can do that very easily. You can use ranges for that. So it's easy to do. The only trick in here to keep in mind is sales is double, right? So if you're not careful, you may get an error. And I want to do it incorrectly in the first place just to show you what I mean. So I'm going to go ahead and do in here select case. So our decision is based on the sales amount. So when I say select case, DBL sales. All right, and this is I'm not being careful in here, and I'm not just checking in here if that this should be really an integer, saying when you do select case. So we're gonna select in here if it is less than 10,000. If it is, mean use the is keyword, is less than 10,000. If it is less than 10,000, then you're gonna have in here. Let's declare a variable for that you have DBL commission rate. Is going to equal 5%, but keep in mind 5% is 5 divided by 100, which is 0.05. So you have to need to know that 5% is not 5, is 0.05, which is 5 divided by 100. The next case, if it is between 10,000 to 14,999 for 14,999. If it is then we're going to say in here DBL commission rate. Okay, I have an error in here. It should say equal. I forgot that. DBL commission rate equal. This case will be 10%, which is 0.1. And the next case is we have the sales is between 15,000 to 17,999. In this case, with the commission will be rate would be equal to 12%. And we have case 18,000 to 21,999. And this will give you commission rate of 14%. If it is 18,000 or more, then the commission rate would be 16%. We can say in here case else. Commission rate is equal 0.16, right? Okay, so this is basically the input, right? And then we're going to compute in here our, once we have the commission rate, then we can compute the commission, DBL commission. Commission is going to be the commission rate times the sales. And then we can compute the net pay, DBL net pay. Net pay is going to be equal to the commission minus the advance pay. This is the calculation, give you all the calculation. Then we're going to do step 3, which is the output. And this is, I promised you that basically, you know, the input and output is going to be very easy to you when you get to chapter 4. So this is, everybody know how to do the output. So we're outputting the labels, LBL. We're going to output the commission rate, dot text. And we can use in here DBL commission rate. That toString, right? But we're going to format it as a percentage, so we can use in here a P format specifier. So it's going to format it as a percentage instead of, you know, currency, right? Then we can output the commission. It's going to equal DBL commission. That toString. but we're going to format that as currency. And the last one is for the advance pay, for the net pay. This is going to give you DBL net pay dot toString. Format that as currency. And this can display the output. Okay. Now, this is look all fine and nothing wrong with it and perfectly fine, but it have a bug in it. It have an error in it, right? And you're gonna see the error, right? Okay. Sometimes we call it a loophole. Sometimes we call it something that people can use advantage of, right? Okay. Let's go ahead and see how we're gonna compute the commission here. 5%. All right. So let's say that the person is gonna sell only. We're gonna have a basically salesperson is not gonna do much work. He's gonna sell $1,000 worth of merchandise. So he should get 5%, right? 5% commission. 5% commission of 1,000 is gonna give you $50, right? You should get $50 commission, right? Okay. Let's see what would happen. Actually, let's make it not one. Let's make it 1,050 cents. All right. This is the key in here when you have floating point value. So I'm gonna go ahead and run it right now. And I want to enter for sales. I want to enter $1,000.50 or 5 cents, whatever it is. This is when you do that. Actually, I'm gonna put. Sorry, I'm gonna put in here the upper bound. 1,000. Yeah, 1,000. 10,005 cents, right? 10,005 cents. So let's see what would happen. Waiting for it to compile. But so when you put 10,005 cents, it's gonna fall between these two cases, right? And it's not gonna match a case, right? So it should give you 5% or 10%, right? Let's see what would happen. It's gonna give you incorrect result, right? Sync, yeah, here it is. All right. So sales, I wanna put in here 10,000, the boundary, 10,000. Okay, and I want to say in here 0.005, right? I'll do it like this, right? Basically, it's practically it's 10,000, right? All right, but because no, my mistake. I'll put 14,999, right? 14,999. This one, 0.005. So it's practically 14,999. But it is not this case. It's not this case. It's not. It doesn't match this case. So you should get 10% commission, right? So it's about $150 you should get, right? Or 10% commission. Sorry, you should get like about $1,500, right? But because of this logical error, it's gonna fall to the case else and give you 16% commission. All right. Instead of getting 10% commission, you get 16% commission. Let's go ahead and try that. So in here, I want to say advanced pay. I want to put 0 advanced pay just to keep that simple. Right. Give you 16% commission. So this is because this is no way near the 15%, right? 16%. To get 15%, you have to make 22,000, right? This is you're probably you're 7,000 below that, so you're not there. So, but you're gonna get the wrong commission rate. This is happening because you're using a a floating point variable for your case. And this is the rule one. You never want to use a floating point variable for your case, all right? Especially if you're using ranges. Always convert that to an integer. Otherwise, it's going to mess up your calculations, right? Then you're going to hit the wrong case, right? So DBL, CINT DBL says, let's run it again with the same number, see how much he's going to get. Now it should give you 10%, all right, or maximum 12%, but it should give you 10%. All right, so I'm still waiting for it to. Did I run it? Yeah, it's kind of slow. So I think I'm running the projector. That's why it's running slow. Whenever I run that, it just slow it down very. Okay, here it is. So I'm putting here 14,999.005, right? This is what we entered before, right? Calculate. No, I need to add advanced pay. Okay. See, this is the error checking. Can give you 0 in here. Let's say calculate. 10%. That's the right way, right? So we're getting it correctly. So we have that. This is basically an example of using select cases. The only thing to remember is when you have the expression should not be a double. Always use CINT if you have an expression. I think the author, he wrote it without CINT, so he have a logical error in his code. So he should use CINT for that. Okay, so let's save this one. Let's move on with the next thing. We're going to talk about input validation. All right, as I indicated, this is very important for programming, is to make sure the input is valid. All right, the saying is that there's a garbage in is garbage out. So you have to make sure you have valid data for input. So how do we validate the data? Let's look at that. So there is a output is only as good as the input. The saying is garbage in, garbage out. Input validation is a process of inspecting user input to see that it meets certain rules, right? There is different kind of validation you do. This try pass is not really a true validation thing, all right? The try parse, I'm going to put it this way. The try pass does something very similar to the try catch. We already learned how to do things with the try catch. And actually, to be honest, the try catch does it better, right? Right. When there are some errors that the system can detect, all right? That means the system will be able to handle. These are called exceptions, right? And there is some errors that only you as a programmer can fix, can detect and fix, right? So, for example, entering non-numeric entry when you should enter an integer or a double. This the system can detect. This is an exception. Okay, it's called an invalid cast exception. Trying to convert, for example, in here, the sales. Let's say the trying to convert the TXT sales into a double. That means you're casting a string, a text, into a double. That's what you're trying to do. You're trying to cast this one into a double, but you fail because the argument TXT sales is not a number, right? This is called an invalid cast exception, right? So this kind of error the system can detect and it can handle. This is called an exception. That's the try catch are designed to handle exceptions, so they are perfect for that. They'll do it best, basically. And there is errors that the system cannot detect. For example, you may have some probably business rules that say an employee cannot work more than 60 hours a week, right? This is a policy, business policy. The system is not going to be able to detect that. This is, you have to implement business rules. And guess what? You implement business rules using if statement. This is how you validate it, using if statement, right? So the try catch and he pass really doesn't do anything more than the try does it. It just does it differently, and even the try catch does it even better, I think. but it handles exception. The try-parse method verifies that an input value is a valid numeric or date format. Decision structures are often used to validate input. Use basically if statement to do that. So anytime when you're saying about validate, you need an if statement. That's what it means. What does the try-parse method does? Okay, the try-parse method, it converts an input value to another format, all right? It try to convert it, a string, for example, to an integer, right? If it succeeds, it returns true. If it fails, it returns false. It returns a Boolean value, the Boolean value true if its conversion is successful. It returns the Boolean value false if it is unsuccessful, right? Each numeric variable have its own each numeric variable type have a try-parse method, right? So you can use integer.try-parse or double.try-parse. Each data type have a try-parse method. Best way to see that is through an example. All right. Let's say that we have txt input, okay, that contain a numeric string to be converted, right? We're gonna receive the converted value, convert and store in IIT number, right? So try-parse is gonna give you true if it was successful, if it can convert to an integer. It's gonna give you false if it was not successful, if it cannot convert to an integer, all right? So for example, in here, we can use an if statement. We can say if try-parse txt input.text, right? Try to convert that to an integer and store the result in int number, right? If it was successful, it's gonna do the conversion, store the result in int number, and return true. Because it returned true, it's gonna put you in the into then clause and display the value is int number. If it was not successful, it's gonna throw you to the else clause because it's gonna return false, and then display cannot convert to an integer. Best way to do this is through an example. So I want to do another example. So I already created a form for that. And this is called the gross pay calculator. Nothing new in here. We used that before. We did that from chapter 1, computing the gross pay, which is the hours times the rate, right? I added a label in here. I added a status label in here at the bottom, right? And I called LBL status to display information on the bottom of the screen, right? So let's go ahead and see how we're going to program that. But we need 3 variables because we have 3 inputs, 2 input and 1 output. We need 3 variables. So let's go ahead and declare them here. So we're going to have in here all of them. We have the hours. Let's make it an integer. int hours as integer, and we have in here the rate, and let's make the rate double. And we're computing the gross pay, and let's make this one a double, of course. All right, so this is basically we're going to do that. Very important. Whenever you have a label on the status on the status bar, it's very important to clear it at the beginning, because if you get something to display, if you get an error message you want to display on the label, if you don't clear it at the beginning, the next time you run it, you're going to see it. So it's a good idea to clear it at the beginning. So at the beginning, I just want to clear this one. I called this label LBL status. And you clear it by assigning an empty string. You can use 2 double quotes to do that. You can do that, or you can do string empty. Either one is fine. So either one will do the job, either equal to string empty, or you can put 2 double quotes. Right, so we're gonna do that. Right. Now we know how to do it using try catch, right? Right. So what we usually do is we use a try in here, and try catch, and we try to input, and if there's an error, throw it to the catch block, and we'll fix that. And this is, I think it's an easier way to do it. I think it's a better way to do it, right? But I want to do it another way. There's a different way you can use it, right? Very important. Either you're going to use it try catch or try pass. Don't try to do both, because if you try to do both, then you will get then you may get more problems, right? So use one or the other, but not both. And in this case, I want to use an if statement. Try pass, you use it always an if statement, right? So the first thing is I want to try to convert the hours, right? So I say if try pass, since the hour is going to be integer, I'll use the integer class. Right, so I'm going to use in here integer.try pass, and I want to try to convert txt hours to an integer, and I want to store the result in int hours. Now, two things can happen. If I enter a valid number, it's going to convert successfully. It's going to store the result in integer. If it doesn't have a number, it's going to display an error message. All right. Now, you can do it like this, and then you do another if statement in here to try to pass the next value. The next value is going to be double, and we're going to say try pass, and it's going to be it should be here txt hour.text. Sorry. So here I want to say txt pay rate dot text. So I want to try to convert pay rate into a double variable and store it in dbl pay rate. Right. Again, one or two things can happen. Either it's going to succeed or it's going to fail. Right. If it succeeds, then we're done. We're ready to go. We have both number is correct. We can do it in here step 2, which is processing, and we can just calculate the gross pay to equal to int hours times the dbl pay rate. And so we can do that, and then we can do step 3, which is output. And in the output, we just display the gross pay, lbl gross pay dot text to equal dbl gross pay dot toString. Convert it as a currency, right? So we can do that, right? So this should be integer.try pass txt hour to int hours. Okay, let's see what the error is saying here. Represent a double precision floating number. Okay, my int hours is defined as integer. Okay. Integer that try parse txt hours that text. Okay, this is an integer. So we're trying to convert txt hours that text to an integer. So it should be integer.try parse. Okay. It is not a member of integer. Maybe it's int32 integer. Here it is. And okay, then we can use int 32. This is, I'm using Visual Studio 2019. Apparently they're not supporting that anymore. So let's call it int 32 or int 16, 32-bit integer. Oh, okay, my mistake, sorry. Integer. There's R missing in here, try parse. Right, so so this is gonna fix it. All right, so so I tried to convert txt hours to an integer. If it succeeds, then it's gonna sort the result in int hours. If it fails, you have to display an error message. So I wanna put in here an else for it. Right, if it fails, we're gonna go to this one and we're gonna put in here lbl status dot text. I'm gonna say in here numbers only for hours. And I want to put the focus on txt hours. And select all the text in txt hours. So like we did with the try catch block, but we're doing now with if else, right? Same with this one. If this one fails, we're gonna try to convert txt, whatever text we enter in txt pay rate, we try to convert to a double and store it in dbl pay rate. But if it fails, we need to put an else clause to handle that. And in here, we're gonna put lbl status dot text equal to numbers only for pay rate. In this case, after we display the error message, we're gonna put the focus on txt pay rate. And select all the text that was entered in txt pay rate. Right. So this is another way. You could have do it using try catch, nested try catch block, which I think it's easier. Or you can use it with this one. Either one will work. So it's two ways to do this thing. There's not one way that all programmers can write the program. Programmers will write program in different ways. And this is another option. You can write programs using the try parse method, right? So let's go ahead and run it and see how this is work. As a rule, if the problem doesn't ask you to use specifically the try parse method, then you can use either method. You can use try parse or you can use try catch. But if it specifically tell you use the try parse method, then you have to use try parse method. So based on the question, what it does ask you, right? Keep in mind, however, use one or the other. Don't use them both, because if you use them both, you will introduce some errors someplace. Right, so I'm waiting for it to start. I just want to illustrate that it worked properly. All right, here it is. So in here, we're gonna put for hours. If I put an invalid value for hours, right? Okay, the try parse is gonna try to convert this string of characters to an integer. It's gonna fail, of course, right? When it fails, it's gonna throw it to the outer else clause. And it's going to say number only for hours. It's going to take you to hours so you can correct the error. So let's go and try that. I tell you in here, numbers only for hours. We're going to select it so you can change that. Let's put in here 40 hours. I'll put an invalid value now for the rate. Right? Calculate. They tell you numbers only for the pay rate. So you're going to select that so you can correct it. And let's say that you have in here $50 an hour. Right? Now, both of them are correct. So both parse is going to work. integer parse is going to work. It's going to put the result in int hours. The double parse, try parse is going to work, going to put the result in the BL pay rate, and they're going to do the gross pay and do the output and everything. Here it is. Now, notice how this is disappear because we put at the beginning LBL status that text equals string empty. Very important, if you're using status bar, always at the beginning, clear that status bar. Otherwise, when you go back to it, it's gonna still have the previous error message displayed there if you had an error message. So keep that there. Right, this is basically this example, right? Now, so this is all about they're using try parse. It's a different way to do things. Personally, I prefer the try catch, but there's another way you can do it using the try parse. A try parse, you have to use it with if statement. The other thing we talked about it last time is you need to check if a value is inside the range or outside the range. To check if a value is inside the range, use the AND operator, right? So use variable if it's greater or equal to the lower bound and variable less than upper bound. We did that last time. Let me see if I can have the thing that I showed you last time. Basically, so basically we did something like that. If you want to get a value between the lower band and upper bound, right? Then what you can do is you would use value greater or equal than the lower bound and value equal to the upper bound. Always you combine with an and greater than the lower bound, greater or equal to upper bound, because this is what you want everything that is greater than this one and less than this one, and then less than lower bound. So you do that always. Okay, so that's how you do check for in-range checking. You can check for out-of-range checking, right? That being, you take it, value is going to be less than lower bound. This is the opposite of this condition. This is used to be greater or equal, the opposite that will be less than. And greater than upper bound. This is the opposite of that condition, right? So you check if it is outside the range, right? So this is part of input validation to make sure that it is the value is a valid value within a range, right? These complement each other. You can use one or the other if you like. You can use the in-range checking to do the processing, and then if it's okay in the then clause and display the error in the else clause, or you can do out of range to display the error in the then clause and do the processing in the else clause. They basically function in a similar way, right? And this is basically what this is, right? Checking for inside range and outside the range. Right. Right. We get to the important thing we're gonna do now in here is just a new two control. They are fun. This is radio button and check boxes. Best way to understand that is to do to jump into an example. And I'm gonna just jump into coffee shop calculator. All right. So I set it up already. I need to add a radio button to select the drink. These you can select them from the control in here, radio buttons, here they are. Simply first select the group box because you want to put them inside the group box. It's very important when you use radio button to put them inside a group box because radio button are mutually exclusive. So if you put them in the form, you can have only one set of radio button. So we're gonna put it inside the group box. So I want to add in here 3 radio buttons. Here it is, 1, 2, 3. All of them are going to go inside the group box, and right, it's not the best way to look at it. It's not, and then I want to put in here the text value and put text coffee tea and soft drink. I'm going to put this one, I'm going to put check boxes. They are listed also alphabetically in here. Here it is. We'll add 3 of them. Let's see. I lost my form. Let me see where it is. Okay, yeah, 3 of them. 3 of them. And again, I'm not gonna spend time on the look of them. I want to select this one. I want to change this one to say cream. Mocha. And amaretto. Right. Naming convention, radio button, you name them with a RAD prefix, R-A-D. So this is gonna call this one RAD, R-A-D, R-A-D coffee. This is gonna be R-A-D tea. And this one is gonna be called R-A-D soft drink. I'm gonna do just a user interface today, and then we'll do this thing on Monday. This is gonna be checkbox. So the prefix is CHK, so-called CHK cream. And CHK mocha. And CHK amaretto. Right. So this is the form. On Monday, we're gonna program it. The important thing that to know in here is when you process radio button, they are mutually exclusive. Because they are mutually exclusive, you process them always with if, then, else if, else if. Checkboxes, on the other hand, they are not mutually exclusive. Because they are not mutually exclusive, you process them with if and if and if and if. So we're gonna do that on Monday. We'll finish up chapter 4 on Monday, and we will start also with chapter 5. So we're getting near the end of the semester. Keep track of the due date for all the assignment, all the exam. If you missed something, let me know what you missed. If you missed an exam or something, let me know so I can open it for you. You can send me an inbox message for that. That's all what I have for today. You have a nice day. I'm going to stop the recording, and then I will take any questions that you may have.